So, we're going to start a little farther into this question. It's 12D again, but we've rearranged or we've expanded and simplified, okay? So we don't have to do that step again. We still have, this was the first equation in the other page. This was the second equation. Doesn't matter which one we number with. We need to put these, when we go to graph, remember I told you, slope y-intercept form. So that means I need to rearrange it so it's similar to this. Y equals mx plus b. So what that means is I need to isolate both equations for just y. They eventually need to be equal to just y. So we'll do the first equation. Sorry, second. It's numbered number 2. It'll be easiest. We're going to move 3x to the other side. It becomes negative. I have negative y. I need to change it to a positive number. So all the numbers on the other side, their signs will flip. So I've set the second equation equal to just y. Now, our slope is the coefficient of x. So in this one, we have 3, and we know it's over 1. So our slope is 3 over 1. Our y-intercept is negative 7 in this question. Our other equation, we need to rearrange it again, equal to y. We're going to move 2x to the other side. Becomes negative 2x. I need to isolate y, so I need to divide each number by negative 3. Y equals 7 over 3, 2 over 3x. So, once again, my slope is the coefficient of x. Slope is going to be 2 over 3, rise 2, run 3. Our y-intercept is going to be 7 over 3. It's a little harder to find in this question here. Okay, so we have our two equations. We're going to graph the second equation. We'll do it in green. We'll graph the second equation first. Our y-intercept is negative 7. Oh, let's make sure we get some numbers here. Okay, so our y-intercept in our second equation, we're doing it in green, is negative 7. So that means I go out down the y-axis to negative 7. That is 1 point on the graph. So I already have 1 point. From there, I use the slope to find my other points. The slope is 3x, or 3 over 1 is our slope. So we rise 3. So that means I go up 1, 2, 3, and over 1. There's another point on the graph. I go up again. 1, 2, 3, over 1. Another point on the graph. I now have 3 points. I technically only need 2. 3, I can be a little more accurate when I go to extend it. So I'm going to connect these points. We have our line now, okay? There's our straight line. You guys use a ruler, connect the dots, just like kindergarten. You guys get that part? Okay, our second equation, or sorry, we numbered it as our first equation. We'll do it in red. Our y-intercept is a little harder to find. It is 7 over 3. Divide it into a decimal, okay? If you divide that into the decimal, you are going to get 2.333333. So, what that means on the graph, we go on our y-axis again. We go up 2 and roughly 0.3, a third of the way up. So it's about there. This is where it gets difficult to graph, okay? So we're not right on a corner of a grid. So you have to be very careful when we go to graph this. Our y-intercept is 2.33, which is the equivalent of 7 over 3. So, my rise is 2. So when I go to rise, I have to go an entire unit. I don't just jump up to the next number. So 1 is a little higher than the grid, just like we had before. And 2, I've now gone 2 over. When I go to move 3, though, because we're on the y-axis, I can easily move 1, 2, 3 over. So 1, 2, 3. Here's another point on the graph, okay? Let's go up again, 2. 1, 2, 1, 2, 3. I now have 3 points on the graph. I can connect these dots. There we go. So, as we found before, here's our point of intersection, and it's at the point of 4, 5. When we used substitution, we found the exact same point of intersection. When we graph it, we just look to where the two lines intersect each other.
I did it wrong.
There we go. Let's take a look at that.
Good job, sir.
Okay, we're going to take up the word problems. Question 14. Menji has $10,000 to invest. She invests part in a term deposit paying 5% a year, and the remainder in Canadian savings bonds paying 3.5% a year. At the end of the year, she has earned simple interest of $413. How much does she invest at each rate? So, we have to set up our let statements.
Oh my God.
Let X represents the investment that earns 5% a year. So that's when she invested in the 5% a year. Yeah, 14. Let Y equal the investment that is 3.5% a year. Okay? So we have our X and our Y. We know that she invested a total of $10,000. So that means some amount of X and some amount of Y is equal to 10,000. X plus Y equals 10,000. We also know that she earned $413 in interest. So, the interest on X and the interest on Y, we have to calculate the two. We have to change these percentages into decimals. 5 over 100, 0.05. Oh, it's not working. There we go. 3.5 over 100, 0.035. So we have our decimals. I'm going to connect them. X is the 5% a year, so I put 0.05X plus the Y, which is 3.5%, 0.035Y. So we end off with our first equation, our second equation, and you can use graphing, elimination, or substitution to solve them. Okay, question 15. A motorboat took 5 hours to travel a distance of 60 kilometers up a river against the current. The return trip took 3 hours, obviously with the current. Find the average speed of the boat in still water and the speed of the current. The speed of a boat in still water is going to be average speed, okay? So, sure, we'll draw a picture. It's going downriver. Blue water, who would have thought? Okay? So the motorboat went from A to B. It took it 5 hours against the current, and it took it 3 hours on the way back with the current.
So would it be net M?
The distance was also 60 kilometers. So both of our equations are going to be equal to 60, because that's the distance they've traveled. We know that 60, on the way there, it took them 5 hours. Now, it was 5 hours times the total speed. On the way there, our total speed, did we forget to do our let statements? We did. Let's go back.
We should make magma instead of water.
What it's going to be, X is going to be the still water speed of the boat. Average speed. Average speed. Y is going to be the speed of the current. Okay? So, its total speed on the way there, sorry, it's not x plus y. It'll be x minus y because the current was in the way. That's total speed on the way there. Total speed A to B. On the way back, the current was helping the boat, so that's x plus y. That would be the total speed from B to A. So, when we go to set these up, it traveled 60 kilometers, took it 5 hours, times the total speed. Now we know on the way there, total speed is x minus y. On the way back, it took it 3 hours, total speed was x plus y. We now have our two equations. You can use substitution, graphing, elimination, whatever you feel, whatever floats your boat. River question? So, we have our two equations. Okay, question 16. One type of fertilizer has 30% nitrogen, and the second type has 15% nitrogen. If a farmer needs 600 kilos of fertilizer, that is 20% nitrogen, how much of each type should they mix together? So, we know, let X be the 30% nitrogen mix. 30% nitrogen, we'll use N. Let Y equal 15% nitrogen. The 20% is the final mixture. We're working with two, 30% and 15%. Now we know that this person needs a total of 600 kilograms. That is a lot of fertilizer.
Well, maybe it's a lot of land. Building a ball. Yeah, I would look into that. Equals x plus y. Did that happen? Yeah.
So, if it needs a total of 600 kilograms, that means a certain amount of x plus a certain amount of y is going to be 600. So our x plus y, 600. That's our first equation. Our second equation, we need to figure out 20% mix of 600. So what we actually have to do is we have to multiply 600 times 0.2. Okay? So our second equation will be 600 times 0.2 is equal to, now 0.2 is 20% as a decimal. Okay? That's why I've used the number 0.2. Same idea up here, 30% as a decimal, 0.3, 15% as a decimal, 0.15. Okay? So, I need to use those percentages attached to the amount of nitrogen fertilizer we're using. So, our X represents the 30, so that means I'm going to have 0.3X plus 0.15Y is going to equal 600 times 0.2. I can simplify this a little. This becomes 120 equals 0.3X plus 0.15Y. And we now have two equations, equation 1 and equation 2. Eliminate, substitute, graph, look at the back of the book, whatever you want to do to find the answer. Okay? So, there you go.